Kyle and welcome to my YouTube channel. For today's project on automatic and fan, these are the components we are going to use. Don't forget to subscribe. The first component we'll use is Arduino Uno, which will act as the brain. This one for controlling everything we'll be doing. Then the next one will be a DC motor, which will act as a fan or the thing that rotates to rotate the fan here. This one will rotate. The other component we'll need is that one there, an NPN transistor. We will need a transistor for our project. Another component we will need is a temperature sensor, that one there. We will use it to sense the temperature that will be controlling or that will be able to control the DC motor to rotate. So we'll use that, the temperature sensor. The last component will be a diode, that one there, a diode. Now let's go to the connection of everything. Okay, the diode here will protect the transistor and Arduino from voltage produced by the motor when it suddenly stops. So if this one suddenly stops, the diode will protect the Arduino Uno, which is the brain, from that sudden voltage or surge of voltage. Then the transistor here, it will enable us to switch because the Arduino Uno is not able to power the DC motor fully alone, so we are going to use the transistor to help in that connection. So that is all. Now let's go to the connection. The first thing we are going to connect is the Arduino Uno will connect it to the temperature sensor. That is the first thing we are going to connect, the temperature sensor. So we'll connect the power to 5 voltage. Power will be connected to 5V. There is the first thing. Then let me change that to red. Let me move it up a bit. There. Power will be connected to 5 voltage. Let me change, and I change that to red. Then the next thing is the volt, or the middle one, will be connected to analog A0. There, analog A0. Let me change that to another color, purple. Then GND will be connected to GND. GND will be connected to GND. There. That one goes to GND like that. Let me change that to green. Good, like that. So the next component we are going to connect is the transistor, this one here. So the first thing we are going to connect, this one here written collector. We are going to connect the collector to the terminal 1 or the minus of the DC motor, this one here, the minus. So collector, we connect it to minus there, or terminal 1 there. Perfect. Then the next connection is the mid one, or the terminal 2. We'll connect it to 9. You can use any number here. So the middle one is this one here, they called the base. So we are going to use a resistor in the base, so we'll put a resistor there in the base like that. Then we are going to connect this one to terminal 9. You can use any terminal you want, but I will connect to terminal 9 there. Then we are going to connect the last one, the emitter. We are going to connect the emitter to GND. This emitter here, we are connecting it to GND. Let me go along like that, then into GND. Remember, you can use any GND you want. That is how to connect the transistor. The next one is this diode here. We are going to rotate it first. Ensure the silver part is facing the red side. This silver part is facing terminal 2, and then put it somewhere there, terminal 2. So the first thing we are going to do is ensure that we have connected terminal 2 to 5 voltage. So we are going to connect this terminal 2 to 5 voltage there, like that. Then let me change it to red there. terminal 2 to 5 voltage. Let me zoom in a bit. Terminal 2 is connected to 5 voltage, this one, and this one is already connected to the collector. Now we are going to connect our diode. Ensure this side with the silver faces the red side. Then we are just going to connect them together just like that. And the other side, on the other opposite side on terminal 1, just like that. Now we are done with our connection. So let's go to coding. Let's go and code it. Let's go and code it and move everything inside forever. The first thing we are going to do is create a variable called a temperature sensor. You can write it as one word, temperature, without any space, temperature sensor, or if you want to put space, you use an underscore. I'm going to use underscore. So mine, I will call it temp underscore sensor. Temp underscore sensor. Just like that, temp underscore sensor. Then I'm going to start coding it. So we are going to set temperature sensor to read in input, to read analog A0. Remember, it's connected to analog A0 there, so that is the first thing we are going to read. Then, because you can't see the reading, we are going to use the serial monitor for that. This one, serial monitor here. Now, for things to appear in the serial monitor, we go to output and pick a block written print to serial monitor. This one, print to serial monitor hello with a new line, but you don't want it to print hello. We want it to print the temperature sensor. So let's start simulation and see. There, the highest 358, 20, 358, 20. So we can see the reading, but now the readings are too big. So to get a nice range that we can use for our project, we are going to do something different. So the first block we are going to get is that we are going to go to math and pick, we are going to math and pick map. Math and pick map. Then inside the first circle, this one here, we are going to put that one there. Then inside this first circle also, we are going to put another one there, just like that. Just like that. Then we are going to read analog. The first one we are putting is to read the analog. This one here, we put it there to read analog AO. Then the first sign is minus. We are going to minus 20, then times 3.4 times 3.4 to range of -20 to 150. That is what we are going to use, -20 to 150. So let me start simulation again. Let's see the range it will give me now. There, the lowest it can go, -20, so it can read a negative number. The highest it can go is 170, -20 and 170. So now let's give it the commands that we need it to use. So the first command is we are going to use a conditional block. In control, we are going to pick if then else. If then else is a conditional block. If this happens, then that will happen, else the other one will happen. Very lame example, if I slap you, then cry, else don't cry. So you can't cry if you are not slapped. So this is a conditional block. We are going to measure the temperature there with it. So the range of the temperature we want to deal with. So if the temperature go to a variable, if the temperature sensor senses that the temperature is greater or equal to 100. So we are, because the lowest is we saw is -20, the highest is 170. So anything above 100, then we are going to rotate this DC motor to act as the fan that is connected to pin 9. So we are going to output and we are going to set pin 9 to high, else we are going to set pin 9 to low. Okay, that way. Then now let's see if our project will work the way we want. So eyes on the DC motor. So we start simulation. Let's use the serial monitor to see the temperature. Now it's 55. See, we said above 100, so let's go above 100. Now it's 100 and it's rotating. As you can see, it's rotating and it's 100, somewhere equal or above 100. Anything above 100, the fan rotates. Anything below, the fan goes off. Fan rotates, fan goes off, fan rotates, fan goes off. Now, in order to just make it more fun, let's add another component here just to make it fun, an LED. We are going to use one LED, just one, to show you that the fan is on and the fan is off, something like that. Then we are going to connect this one too. Let me go just this side. We are going to connect this one to number 8. Let me use number 8 there. And the other one we are connecting it to GND. Let's go to this GND here. Though I should have, let me use the other GND up there. There. That GND. We just want it to turn on to tell us that it's rotating. So code, we are going to set it's in pin 8. So we are going to set pin 8 to high, else we are going to set pin 8 to low. It's just something visually that if it turns on, it means that the DC motor or the fan is rotating. So let's see. Let's go above 100. There, the LED is on, the fan is rotating. Below, the LED is off and the fan is not rotating. So that's how to create an automatic fan. So don't forget to subscribe if you enjoyed the project.